Welcome to another edition of Sensei Security School. Today we're going to take a look at a solution to the problem of poorly chosen passwords. Many organizations have password complexity rules, things like you have to use uppercase and lowercase, you have to use at least one digit, one number, or you have to have punctuation marks. So that results in passwords like password1 exclamation, which is a very common password. Also things like company name 2021, also pretty common for whichever company name. Arguably, these complexity rules actually make it easier for the bad guys because they know the format that passwords are going to be in. They know that these types of things are going to be very, very popular. And they don't have to check things like, oh, I don't know, maybe this. That's not an allowed password, so the bad guy doesn't have to check that. And in fact, there are readily available lists of the top 10,000 passwords that are used, the top 100,000. And the bad guys can just run through those and get access. So we need something other than these rules to prevent these kinds of passwords from being used, particularly on high value machines. There is an open source tool to take care of this issue, OpenPasswordFilter, and that's what I'd like to talk to you about today. There's a new version out of OpenPasswordFilter, new as of July 2021. I took the previous version and made several improvements, made it much more efficient, so it now is able to check the top million passwords and do so in under a millisecond. So there's absolutely no lag or delay in changing a password because it's using an index that's extremely fast. An updated installer, clean things up. You can download the source and you can compile it yourself because it is open source. You can also just download a binary release here and run the installer, which is what I'll do here for this demonstration. We have OpenPasswordFilter release. We'll just run setup.exe. We can install it in the default location here for this demonstration anyway. And it's that quick and easy. Because it hooks into the Windows authentication, we actually do need to reboot the system in order for it to take effect. As of the time of this video, the installer does not prompt the user to reboot. That may change by the time that you see it, but something to keep in mind, the machine does need to be rebooted, the domain controller. What the installer is doing is first it includes a DLL, and Windows loads this DLL into the password change process. Windows then asks the DLL, is this password okay? And this is based on a registry key. It's a registry key that determines which DLLs are used for password filtering, for deciding which passwords are okay and which passwords are not. Because that's loaded into the Windows authentication process, we want to keep it very, very simple. We don't want it to fail, obviously. So the DLL itself doesn't actually check to see if the password is allowed. All the DLL does is pass it over a local named pipe to a Windows service. So it's just very, very simple, small DLL, does a very simple job. If it doesn't get a response from the service for some reason, it goes ahead and allows the password as though the filter were installed. So if something breaks, it's like you never did anything, your Windows continues to work. That's kind of a design criteria for this system. Once it's installed, you will see and rebooted, you will see the service running. It's actually called Password Checker. It wouldn't hurt to check and make sure it's running, just to be sure. And here it is, and it is running. So let's try changing a user's password now to something stupid, like password1, something that's ill-advised. Go ahead and go there to reset password, and I'm going to type password one. If I can type correctly, I'm going to type password one exclamation mark. That meets the policy. It has uppercase, lowercase, a number, a punctuation mark, but obviously it's a poor choice of password. And OpenPasswordFilter here is denying it, saying that doesn't meet policy. To test and confirm, we'll go ahead and try resetting the password to something that is good. And I'm not going to tell you my good password because that wouldn't be smart. You don't need to know my password. Sure enough, it's accepted. OpenPasswordFilter installs in that directory that by default we saw what directory it is, CompuInfoSec in this case, password checker. It includes 2 lists of disallowed passwords. OPFmatch.txt is by default the top 1,000,000 passwords. In this case, they're actually all marked or recorded in lowercase. Any case will be rejected, right? Password one is not okay no matter what casing that you use. Also, you may have a password that's already commonly used throughout your company, something like company name 2000. And you don't want people changing passwords or setting passwords to that anymore, but it's already in use. If it's already in use throughout your company, it's kind of a default password, maybe a default admin password, maybe you don't want to list it here in this file at the bottom of the file because you don't want bad guys to see. If a bad guy were to get in here, get some kind of read access, you don't want them seeing that that's a password. You don't want it in plain text. So there's also the SHA-256 version of it. You can go to any website. You can just Google online SHA-256, paste in your password, or well, probably you shouldn't do it on there. Shouldn't do it on the web. Lots of ways to make a SHA-256, and the readme.docx file actually gives some PowerShell for how to generate a SHA-256 hash if you're not familiar with how to do that. Yes, here it is, right here. This docx that's installed will give you exactly how to generate a SHA-256. And it will give more information as well. For example, here is the registry key where we set up which DLLs are used for password filtering. So there's more information in there. But pretty much all we needed to do is download and run the installer, reboot the machine, and now we're protected.